Hey, hello everyone. Welcome back to the day 6. Today we are getting started with functions. This is the video where I'll be introducing functions to you along with different features or different ways where you can utilize functions in your programming. So far, whatever we have learned in the last 5 days, everything together we are going to use in our examples, task assignments, and the programs while we're learning functions. So let's quickly see what are the things we want to cover today. We will get started with understanding what is a function, then we'll learn how to define a function or declare a function, how to use function as an expression. We have learned about expression already before. Then what is default parameter and what is rest parameter. These two things we'll understand. Then we'll understand how to nest multiple functions together, one inside another one, and what is the use case. And we are also going to talk about callback function, then going to talk about pure function and HOF, higher order function. We're definitely going to look into arrow functions. We'll be understanding what IIFE is. And then a grand topic is about call stack, like how function gets executed. And then finally, we'll end this video with recursion. So we have lots to cover, and I don't think that time should be a boundary because I don't want to teach you JavaScript in 60 seconds. I want to teach you JavaScript in depth, and for that, whatever the time is required, we will take that time. Give it once so that you can reap the benefit of it for the lifelong. There are a few things that we won't be covering as part of this video, though those might be related to functions. For example, hoisting, scope, and closure. The only reason that why we won't be covering as part of this because each of these things demands their individual sessions. And if you look into our session list for 40 days in the progress tracker that I have shared with you, these things are very well conveyed that in the next module that we are going to start soon, the first 4 videos of that going to cover execution context, scope and wasting, closure, and also about this keyword. So we'll be utilizing everything that you will be learning in this video into the following modules in the day 8, 9, 10, and 11. So don't skip anything from this video, any of the fundamentals, because it's going to be very useful for you. So why waiting? Let's get started. Before we get started, as usual, a request will be if you have not subscribed to tapaScript, please subscribe. I spend a lot of time to create quality content for you. If you subscribe, it will be a great motivation for me as a teacher, as a content creator. And please like this video, please comment here. And one request would be, could you please share about the 40 days of JavaScript on your social so that more people can come to know about it, and do it only if you're finding it useful to you. All right. So let's get started with functions. What is a function? I would define function in this way. Function is a methodology in programming using which you can save yourself from the repetitive task. It means that if you have bunch of lines that you repeat most of the time in your programming, it makes sense not to repeat those lines every time you need it. Rather, create a function with those lines together and use that function instead every places wherever you had those lines required. So that means you are creating some amount of reusability. Also, the time and effort to build a program is also reducing as you will be writing the code once and trying to use it in multiple places. So this is how I define function in programming. In mathematics, there is a definition of function in this way that function is something which maps its input to the output, which is also true. And we are going to see that in a while when we are going to talk about parameters and the arguments. But for now, let's focus on this diagram that you're seeing on your screen, which shows that you have a bunch of lines of code in your JavaScript file. If you are able to see these colors clearly, there are black colors line like the first 3 line, and then again in the middle 3 black lines, towards the end 3 black lines. That indicates the same line of code, exactly same code, same expression you are repeating multiple times in this file. Now, instead of doing that, what we can do pretty easily is we can mark these lines that are getting repeated and then refactor those lines into something that we'll call a function. That function usually will have a name. We'll see that when we define the function. Let's assume the name of the function in this case is fun. And then instead of repeating those lines again and again, what we can do, we can just remove those lines one by one and then call that particular function instead in those places, so you can clearly see that number of lines of code that you had written in the left side and what you have got after refactoring in the right side is much lesser. Also, in future, if you need this function elsewhere, you can utilize this function elsewhere as well using its name. And once you call that function using the name elsewhere, the lines that are written inside the function will be executed. So it will have the similar effect programmatically, output wise, from the left side to the right side, but you have achieved reusability and you have written less number of code in this case. So this is what is function at a high level. Let us now learn how to define a function. The most easiest way to define the function is using the function keyword. So you will use the function keyword followed by your function's name. Let's say your function's name is print this. And then you have to give a pair of parentheses, and then you have to give a pair of curly braces. This is the syntax. You start with the keyword, then any name of your function, then a pair of parentheses, then a pair of curly braces. Now, the name that you'll be providing in terms of variable, we have already learned that use case based name or a name that is suitable to the circumstances is what is most useful. In case of function also, it is same. So when I say print this, I want this function to print something, right? So that's the cause for this function. So while naming it, you have to remember. And then you have the parenthesis, and there are few utilization of it that I'll come to that. But let us focus on something called function body. You create a function body using this pair of curly braces, and inside this function body, you define what exactly the function is supposed to do. Our function is going to print something on the console. So I am going to say console.log of printing a message. So it means that the body of this function is having only one console.log. So this is what we call a function definition, or there is another name, don't get confused, it's called function declaration. Both function definition and declaration are the same thing. Now I have defined a function or I have declared a function. When you define or declare a function, the function actually doesn't do anything. It is something like declaring a variable, but you have not used that variable anywhere. Similarly, you have declared a function, but you have not utilized the function at all. To utilize this function, you have to call or invoke this function. Another terminology, call or invoke. To call or invoke a function, you have to use the function name. If I want to call you, hey David, I'll call you by your name. Hey Ravi, I'll call you by your name. So similarly, you can call the function using its name. So in this case, the name is, of course, print this and followed by the parenthesis. Okay, you can give a semicolon optionally. Now, if this is happening, it means wherever in your code execution, JavaScript interpreter is going to see this print this followed by a parenthesis, but there is no function keyword before it. There is no function body curly braces after it. That means you are actually calling or invoking this function. So this is the syntax for this. So I've called this function. Let's go ahead and see the output. I'm expecting this particular function is going to get executed and it will be printing this on the console.log. Of course, I see this here printing, so it's working. So we have seen a common way of defining a function. Now we want to learn function as expression. What does it mean? Let's see. When you create an expression, how do you create an expression? You have something called an assignment operator, which is equals. At the right side of it, there will be some value. At the left side of it, there will be a variable. And that variable, you do usually a specifier like let or const. So do let print me a variable name. And in this variable, you can assign value, isn't it? We have learned about primitive, non-primitive. While non-primitive, I mentioned there are three types usually. One is array, object, and last is function. So that means function can be a value that you can assign to a variable. So I can actually write this function as a value to this particular variable, print p variable. It's a legit one. Instead of assigning a value 10, you are now assigning a function. So print me is a variable whose value is a function. Now if I do console.log of print me, We used to create a variable, assign something to it, and then used to do a console.log of that variable. Same thing I have done here, but here only difference is the value is a function. So let's see what this prints on the console. What I'm seeing, it has printed a function. So it proves that the value I have assigned is got assigned correctly because I'm able to print that exact function over here. Now we know already that to execute a function, we just have to give a parenthesis after that. So if I need to execute this print me as a function, what I'll do, I'll just do print me and then the parenthesis. That's it. Because this print me is already holding this particular function as a value, and then I have the parenthesis, so the function will be executed. It's exactly the same thing. Print this was the name of the function and the parenthesis when the function was invoked or the call. Here also we are invoking or calling. Only difference is here we have defined the function in the normal common way. Here we have assigned a function as a value to a variable. That's why we call it function as an expression. And then as the function is there in the variable as a value, I can use that value followed by the parenthesis so that the function gets called and invoked. Simple. And of course, here goes the output. While defining function, I told you there is a mathematical definition of a function. Function is something that maps input to the output. That means you will provide some input to the function. Function will do some calculation based on that input and it will produce some output. That's what the function does in mathematics. In programming also, apart from the reusability factor, function is also going to do some wonders about mapping the input to the output. It means some calculation inside where it can take the input, do the calculation and produce an output of it. Let's see that factor as well. For that, I'm going to create a function called sum. Now we are talking about a function taking inputs. A function can take as many number of inputs that it wants to, but in real life programming, we probably won't see too much of inputs that a function is taking because the code looks lot bloated. We follow some good practices, clean code practices. We are definitely going to cover those towards the end of 40 days, but let's assume for now that you can pass as many inputs to a function. The input that you pass to a function is called parameters. And this is where we are now learning parameters and arguments. How do you provide those input to the function? You will provide those input to the function in a comma separated way. For example, you can give a comma b over here. It means that this particular function takes two inputs. One is a, one is b. If you wanted c, then it will have comma c. So it means that this particular function takes three input, a, b and c. Let's go with a and b only for now, and then you will have this particular function body. Inside this function body, you want to do whatever you want to do. For example, I can do const result equals to a plus b, and then can do console.log of this result. So this function is doing the summation of two numbers, for example, and then it is printing that result of it on the console.log. Now, if I have to do summation of two numbers, any two numbers that users are passing without a function, I have to call this line multiple times. Results equals to a plus b, a plus b, a plus b, with a and b being different numbers that will be passing. But in case of function, the usefulness now is I can call this sum function as many times as I want, passing the values for a and b, so that the value that a will be assigned to, value that b will be assigned to, can be summed up, can be stored on a result, can be printed on a log. That's the advantage of the function. But here, along with that, a great thing that we are doing, the flexibility of passing input to a function, that is with a and b. This a and b, while declaring or the defining the function, whatever the input you put inside this parenthesis are called parameters. Please remember this very clearly. The input that we pass to a function while declaring it, this is important, or defining it, is called parameter. They also call placeholders. But when you invoke or call this particular function, this is the time you will be passing the actual value that will be replacing the a and b. So for example, 10 comma 4 if I pass, this 10 will be replacing A. That means the 10 value will be assigned to A, 4 value will be assigned to B, and here 10 plus 4 will happen 14. Result will have 14 and console.log will print 14. The value, the actual value while invoking or calling the function that you are passing is called argument. So this is the difference between parameter and argument. Sometimes you get harassment in interviews asking what is the difference between parameter and argument. Parameters are the placeholders or the variables that we pass as an input to a function while declaring or defining the function. On the contrary, arguments are the actual value that will replace those declared variable while invoking and calling the function. That's the definition of it. Please write in your note and please practice it. Parameter and the arguments. Now we know parameter, we know arguments. The one more important thing that we want to learn over here is called return statement. What does return statement mean? Let's learn that. In this case, the function has done some work. So for example, function has done a summation of it and then it logged the result into the console. Excellent. Function's job is done because summation, it will work. If I see the output, I see the output is also showing 14. But let's think of a scenario that this summation, this result, you want to utilize elsewhere. Maybe you are writing a program where you want to take the result of the summation and then somewhere else you want to multiply with 2. Somewhere else you want to multiply with 3. So it means this particular summation result, you need it everywhere. So just doing a console.log over here is not going to suffice. Your function needs to return this result some way from this function so that elsewhere, wherever you are calling or invoking this function, you always get this return value and you can work with the return value further. So for that purpose, you have to use a keyword called return. After that, you give a space and then give what you want to return from it and then give a semicolon. Very important. Return and then what you want to return from it and then a semicolon. Now, if this happens, in this case, I'll just comment out console.log. Wherever I am invoking this sum function is going to return me the result of the summation of these two variables with the value that I am passing over here. So this return value, whenever something is returning you something, you can hold that return value in a variable using expression. Again, what is expression? There will be an assignment operator and right side of it there will be value. In this case, what is returning? The sum. So the value say 10,4, and at the left side with a specifier you can define a variable. So now this sum function returning this particular result will be inside this variable. So if I do console.log of result, I have commented the console.log here. I have given the console.log only after I am getting the return value in this particular result variable, and I am expecting that when I go to my browser, I'll be able to see 14. Great. Now the great thing is, instead of 4, if I do 9, I don't have to change anything in my function, because this is why we have created the function from the reusability sec, and this is going to give me the result as 19 expected, right? Now taking this result, I might want to do further thing. So for example, I can have another function, say double, which takes a parameter and return whatever I have passed as a parameter multiplied by 2. So it's always double up the value, right? So here what I can do in the console.log, I can just simply call this double function and now pass this result. See the beauty of it. So here with the summation, I have passed A and B values, got the result over here, and the same result I am passing to another function called double. I am passing this function over here. Now this double you could have invoked outside. Again, the return value can be taken in a variable and you could have passed just that variable to console.log, or you can do in a single line like this. Here only I want to invoke double passing this result. So this result value here was 19. Now this result value 19 will be passed over here and it will return 2 into 19, which is 38. So console.log of double of result will be 38. If I go to my browser console, I can see 38 printed over here. Great. So we have learned defining a function, expression, parameter, argument, return statement, all the things together. One point to note over here, very important. You must be giving what you want to return beside the return statement. Please do not ever give an enter over here. And if I just go to my browser now, I see something called NaN, not a number. If I just comment out this line and try to see console.log of result, what I'm going to see here is something called undefined. So crux of the story is, if you are returning something, make sure the return value is in the same line of your return statement. Doing them in the next line is going to return an undefined from here. It is not going to look into anything after the return statement, because once you give the return statement, you are returning from the function straight away. It is not going to execute anything in the next line. So make sure that this error you don't do, because it is not going to give you any kind of syntax error. It is just going to simply return undefined. So always this way. So friends, let's learn the next topic, and we will learn about default parameters, what exactly it is. We know about the parameters by now. Now for default parameters, to demonstrate that, let me create a function. So let's create a function called calc, and in the calc function, again, we are going to take two parameters, A and B. What we are going to do here, we are going to return, because we know about return already. And what we're going to do, we are going to first make a summation of A plus B. You guys already know about grouping in expression. We have learned that. And then multiply that with a multiplication sign and with number 2. So how can I test this? I can do calc of 2, 3. What will be the output? 2 and 3 will go here. 2 plus 3 is 5 into 2, 10. That's what is going to be the output. Great. Now, if I omit this guy, let's say I do calc only 2. And as usual, let me just take this guy into a variable and do a console.log of this result variable. So the output I see here is NaN again, not a number. That means some number operations has gone wrong. If I go back to the code, so what is happening, let me understand. Here for calc, I have two parameters, but in the argument level, I have passed the value of only one. Now with the order that you're passing the value as an argument over here, that's how the mapping from the argument to the parameter will happen. So here this 2 will be assigned to A. That means A will have the value 2. Then how about B? If you just create a variable and not assign to any value, what exactly the variable will be? Undefined. We have learned that in the variable session. So B is here undefined. So at this point over here, you are trying to do a summation between number 2 plus undefined. 2 plus undefined over here, you will find a NaN, not a number. So that's exactly the thing that is happening over here. And once you do any multiplication, any division on top of not a number, you will get again not a number back. Now in this kind of scenario, if you want to make your code as fail safe, that means it will fail means fail gracefully. In that case, you can use something like a default parameter. So I can actually manage this particular program now with default parameter. How can I do this? Here, the default parameter value is something that we can set as 0. So default parameter means a parameter which is having a default value. So here I'll be setting this value as 0. It means now A will have the value 2, B is already having a default value 0. If you don't pass anything, B will always carry that default value. If you pass something, that default value will be overridden with the value that you are passing. Now, as I am not passing anything, so A will have 2, B will have 0. So 2 plus 0 is 2, 2 into 2 is 4. So if I go to browser, I can clearly see it is 4. Now here, if I pass, say, 7. Now this b equals to 0, the default value will be overridden with this particular number 7. Now b will be 7, a will be 2, 2 plus 7 is 9, 9 into 2 is 18. You can see it is 18. So this is how you can give a default value to a parameter. If you want, you can make both of them as default. So if you don't pass anything, for example, in this scenario, what is the output is going to be? 0 plus 0 is 0, 0 into 2 is 0. So when you don't pass anything, the output is going to be exactly 0. Otherwise, it would have resulted into and not a number. In that case, a and b would have been undefined, and again, undefined plus undefined will be not a number. Excellent. Default is done. Now next, we are going to learn about rest parameter. Rest parameter, as the name suggests, rest means you have something and the rest of the thing, right? That's what rest mean. In JavaScript, the function can take any number of parameters. So if I have a function, say calculate this, it can take x, y, u, o, whatever the number of parameters that it can take, right? But sometime in programming, it might happen that you are passing arguments for all these parameters, but you really don't know, like runtime, how many arguments may be passed to this particular function. So you cannot really define the exact number of parameter while creating this function. So this calculate this, if I now just take and try to call this with the arguments, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have passed 9 arguments over here. But number of parameters that I have defined over here is 1, 2, 3, 4. Then how about the rest of the 5 values that I am passing as an argument? How can I hold it within the function so that I can utilize them? If I don't know runtime how many arguments might come to this particular function, I won't be able to define the exact number of parameters for them. That is when the rest parameter comes very handy. Let's say you are aware of first 2 arguments. That means first argument is x, second argument is y. But now you are not aware of rest of the argument, like what it is going to be. In that case, you can use this 3 dot operator along with a name of a parameter. You can give any name. What people give as a practice is called rest. So now what will happen? This 1 will be mapped to x, this 2 will be mapped to y, and from 3 to 9, all these argument values will be mapped to this particular parameter rest. Now you will ask, how can multiple values be mapped to one single parameter? Yes, we will learn about arrays in future. What will JavaScript do? JavaScript will create an array, which is a collection of elements, collection of values, and assign that array as a value to this particular variable. That's what JavaScript is going to do. So if I am going to do console.log of x, y, rest, let's see what I'm going to see. I'm going to see x is 1, y is 2, and rest will have an array. Inside that array, these other things will be there as an element. As you see over here, x is 1, y is 2, and rest are there is an array as the element. 3 to 9 is inside an array. One golden rule though, the rest parameter can never be the first parameter. You have to keep in mind, or in the middle. The rest parameter always need to be the last parameter. You cannot do this. If I go to the browser now, this is going to fail royally. Is saying that rest parameter must be the last formal parameter. Okay, so you have to keep this in mind, because sometimes I have seen people are getting error like this. So that's about default and rest parameters. Hope it is clear. Let us now learn about something called nested function. So what is nested function? When a function inside another function, then we call it as nested function. In that, with nested function, there are 2 more terminologies that will come. One is called outer function, another called inner function. The function which holds another function inside it, it's called outer function. The function which become a function inside another function is called inner function. So let's write them so that we understand it very clearly. How do we write a function? Of course, function keyword, and let's write something called outer. Inside this outer, now you can have a console.log just to check that this particular function is getting called and it is getting printed. So we'll call it outer. And then inside this particular function, you can create another function and can name it as inner. You can give any name. Just for our understanding sake, we are giving it as inner. Now we'll do console.log and then we'll do inner. Here we have defined one function, and inside that we have defined another function. Very clear. This particular inner function, listen carefully, this particular inner function, if you want to execute, you can execute this particular inner function like this inside, because this particular function's existence is not there outside of this outer function unless you are returning this function from here. We will learn this rule much deeper when you go to scope session, but for now remember or write this rule. If you are defining a function inside an outer function as an inner function, you can call this inner function only within the outer function. You cannot call this outside. Okay. So far, I am calling this one over here, inner function. But unless the outer function is getting called or invoked, there is no way this inner function will be invoked. Why? When I am going to invoke this outer function over here like this, the outer function will go line by line. It is going to execute this console.log, then it is going to define this guy, and then it's going to execute this. So what I'm going to see, I'm going to see an output called outer, and then I am going to see something called inner. Outer and inner. Okay, so that's the sequence. Now let's try this one out. Let's take inner out and try to execute inner outside of the outer function. Okay, will it be done? Let's see. It says reference error, inner is not defined. Why inner is not defined? Because we have declared inner inside this outer function. Here, what JavaScript creates is something called functional scope. We are going to discuss in detail about functional scope in the scope session. But for now, whatever you're defining inside this one is called functional scope. Anything you define within its function scope is not accessible outside of the function scope. So it means that as you have inner over here, this inner is not accessible over here. This inner is only accessible inside this particular outer function. So that's something that you need to remember. But is there any way that you can make this inner available in such a way that it can be accessed outside of the outer function? Is there a way? Yes, there can be a way. What is the way that it can be? Instead of invoking it here, you can now return this guy from here. You can do something like this: return function inner from here. Now when you are actually invoking outer, just like returning 20, returning tapaScript, returning abcd, returning true, now it is returning a function, isn't it? So outer can have a return value, say ratefunc variable. So ratefunc variable, when I say equals to outer, outer will return this particular inner function, isn't it? We learned about return already. That means if I do console.log of ratefunc and go to my browser, I will see this inner function. Great. Now, if I have to execute this inner function, what I have to do? Just need to give a parenthesis. We have learned this before already. So if I just do this parenthesis, that means my inner function will be executed. Now I'll be able to see this console.log inner. Console.log inner. Awesome, isn't it? So this is how you can deal with outer function, inner function. Now, if you understand this concept of how I can return a function from an outer function, or returning an inner function from an outer function, and then executing that inner function later point in time, you are taking the first step towards understanding the concept of closure, which again we will get into the depth in the next session. That's why I don't want to combine everything. This is an introduction to function. I'm giving some introduction of the topic to you guys, like to deal with the inner functions. If you learn this, if you practice this, what I'm doing, once I am going to explain about the scope and closure, it is going to be like a cakewalk for you. Believe me, it is so easy. Closure is actually easy. You just need to understand this concept. So I hope this inner function, outer function, How can you execute an inner function within the outer function? How can you return an inner function from an outer function and execute it later? It is very, very clear to you. Rest of it is in the scope and closure session. Let us learn about callback function. As the name suggests, callback means call me back after some time. It means a function that you can pass as an argument to another function and call that function that you are passing at some point in time based on some condition. Let's take an example. So here is a function called foo, and as a body of this, I'm giving a text to print called foo so that I know that this is the foo function got executed. Now this function can take a parameter which can hold the value of a function. Let's have a parameter called func. Okay. Now this func parameter I can call somewhere in this particular function's body, and as I'm expecting this to be a function, I will give this parenthesis after this so that I can execute this function. For executing the function, we always use the parenthesis. So func, after that, if I give this parenthesis, means I'll be executing this function. Excellent. Now, when I call foo, I can now pass a function. I can pass a function call console.log of buzz. What I did over here, a few things. Let me explain. From here to here is a function. But hold on, there is no name to this function, isn't it? I have not given any name. I told you when you define a function, you give the function keyword and then the name, but here no name. Yes, you can create a function without a name as well. That particular function will be called as anonymous function. But why would you create a function without a name at all? You will give a function a name only because after defining the function, later point in time, you want to invoke or call that function using that name. But if you don't have to invoke or call that function at a later point in time using its name, rather you want to define the function and pass it along on the same time without a name, that is where you will be using something called an anonymous function. In this particular case, you are passing the function as a whole. So this function as a value will be now assigned to this func variable. Now this func variable is having this particular function. So when I'm doing func and after that this parenthesis, that means I'm doing this function. After that the parenthesis means function will be executed. Here I don't have to give any name to this function because it will be passed as it is as a function, as a value to this particular variable. We have seen it something like this. func equals to something like this. So here exactly the same thing happening. Func is a variable and this function over here, this particular thing is getting assigned like this. Okay, imagine in this way. So you don't need a name. Now if I execute this, what will happen? Foo is getting called over here and I'm passing this function as a callback function to this foo so that I can call this function back later point in time whenever I want. I'm calling it after this console.log foo. So if I go and see output, I would see foo and buzz. Why I'm seeing foo and buzz? First, this function when it is executing foo, first line is console.log foo getting called, and then this func I'm executing over here, this func is nothing but this particular function. If it gets executed, this console.log will be executed, that is buzz. Now if you want to create a name function, what will you do? You won't do it in this way. Now you will be doing something like const buzz equals to this, and now you are passing this buzz over here. The effect is exactly same like before, right? So when you have to do a name function versus when you don't have to do a name function is up to you. I can see same foo and buzz. Another thing about the callback function is usually the callback function will be called based on a condition. Let's see, const, I'm doing it like assigning it with true. Now I can do a if condition over here. If only in that case I will be calling this function. So it means I am now putting this callback function inside a condition that only if this condition met, then only my call back will be called. Then only my function will be called. So there is a question that comes in interview very often. Who calls the callback function? Who calls the callback function? A callback function will be called inside the function where we are passing the callback function as an argument, but it will be called based on your business case and the user logic. Here business case and the user logic is if to call buzz is true, then only you are executing it, otherwise you don't execute it. So in this case it will be executed, but if I make it false, what I will see only this console.log of foo. This won't be executed because this won't be called, because this particular condition will result into false, and if false means it don't go inside this if block. So I see foo alone. Hopefully callback is clear. I am going to revisit callback again when I'll get into the module of asynchronous JavaScript. We have a module for asynchronous JavaScript. There I am going to teach you something called callback hell. Using callback, how can you go to a programming hell so that you don't use callback? And for that again promise came. Then from promise, how this async await came, asynchronous programming, synchronous programming, all this thing in that module. That time I'm going to revisit again callback, and that is why this session is important, that you learn the basics of it, so that time you won't be scratching your head saying that, hey, what is callback and when it is getting called. Okay, I hope it is clear to you. So now let's learn about another functional concept, is called pure function. And this particular concept is very essential when you go for component driven architecture like in React or any other programming language in that matter. So you have to understand what is a pure function. You have to understand like what is a side effect, the meaning of this terminology is basically. And again, some of the things like the side effects and all these things we are going to use later in the 40 days of JavaScript, when we handle asynchronous call using JavaScript Fetch API, we'll also see these side effects in actual realization. But now the concept, pure function and the side effect. What is a pure function? Pure function is a function that returns or that provides the same output for the same input. So it means as long as you're providing the same output, it is supposed to give you same. As long as you are providing the same input, it is supposed to give you the same output. This brings a lot of predictability in your program because the function is not doing something else that is not part of its programming logic or the business logic. A function, its primary job is to compute something and give you back. But if it is not doing only that, if it is doing also something else, that something else is what we call side effect, because that something else might have some influence on what exactly this particular function is producing. Let's take some example and try to see a very simple example. Let's create a function and we will say this function name is greeting. And what is this function doing is taking a name as an argument, and over here it can just do a return of hello plus name. I have not taught you the string template literals yet, so I'm not using that. I'm just using the concatenation. But from the session, I will teach you template literals. You will never use the concatenation. Okay, that is prohibited, using this concatenation with plus. But just for time's sake, I'm using it. Now I have this greeting function. So if I call greeting, I pass tapaScript as an argument. So the name is tapaScript. So it will return me hello tapaScript, right? It will always return me hello tapaScript. So if I put this one inside console.log so that I can print it over there, that's the only purpose of it, and go to my browser, I will see hello tapaScript. Now, if I give the same input like tapaScript 1, 2, 3, 4, 5, whatever the times, 5 times, I am going to see the same output on my console, isn't it? I'm going to see hello tapaScript exactly same time. So I can tell this particular function is a pure function because for same input it is producing the same output always. If you give tapaScript here, it will say hello tapaScript. If you say Google here, it will say hello Google. If you say Facebook here, it is going to say hello Facebook. So for the same input, same output. But let me change this one little bit. So the greeting one, I'm going to change it this way. I'm going to create something called const greeting message equals to, I'm taking out this hello from here, I'm assigning over here, and I'm taking this variable and putting it over here. So now same greeting function, but instead of defining this greeting message inside, created this greeting message outside. Now this greeting is getting tapaScript. So tapaScript, tapaScript, tapaScript. I will see the same output. Hello tapaScript, hello tapaScript, hello tapaScript, hello tapaScript. It's just like before. Then what is the problem? What have I done? What change I have done? This particular change that I have done, it actually made this function as an impure function. But how? For the same input, it is giving the same output, isn't it? Oh, is it? No, it is not. Because for input tapaScript, it is giving me hello tapaScript now. But if I change this guy, this hello guy, to something like hola, now if I see my hello tapaScript has changed to hola tapaScript. So that means this particular function that I'm seeing, for the same input, there is no guarantee that is going to give the same output. It might happen that this to line is giving me this hola. So this hola, it is giving me hola. I'll do it let. And then after this to line, I will change this greeting message to say namaste. So for same input, we're expecting same output, isn't it? But for this to line, it is going to say hola tapaScript because this time the greeting message was hola. But now I have changed the greeting message over here. Now if I call it, it is going to say namaste tapaScript. You want to see that? So you see first to hola tapaScript, then namaste tapaScript. So it means that for the same input, it is not going to produce the same output because its output is quite influenced by something that is outside of the control of this function. This particular something which is outside of the control of the function is called side effect. Okay. So ideally, you should try to make your function as much as possible pure function because you have a predictability. It is easy to debugging and all these things. But in real life, it is really hard to make every function as your pure function because you will definitely have some side effects. For example, you'll be making an API call, get the data. Based on the data, you will be doing something. Now, API call will respond back the data based on different kind of parameters and the condition that you pass. So there is no guarantee that every time your function is going to return the same thing based on the same input. It will vary because that's how your application will try to react. But try to make sure that you break your big functions into smaller function so that there are some amount of function that are really pure function. They are going to produce the same output for the same input because that purity is really required for your functional programming and the programming to be very clean. So I hope the pure function is clear. Now we are going to learn something called HOF or the higher order function. Let's learn higher order function. A higher order function is a function that takes another function as an parameter or argument and can return a function from it. Now you might get confused a bit with the callback function because in callback function we told like a function that takes another function as an argument and it execute that function at some later point in time. That's why we're calling it callback function. But higher order function is like either it can take another function as an argument or it can return a function from it, right? Let's try to write both of them so that you understand them. So I'll have function get camera and here it takes camera information, for example, and then this camera is a function so I can execute it. So this is one of the fact. The function can take another function as an argument. Now, if I have to call this one, say get camera, I can pass a function over here and this function can have any body. Let's give a console.log of say Sony. I like Sony camera. And if I am executing this get camera over here, this function gets passed as an argument to this particular camera and I'm executing it just like how we have learned in the callback function. So this is going to give an output of Sony, okay? Because that's the console.log that we have given. Now this is one part of a higher order function. The other part of it could be that a function that can return another function. So let's write that. A function, let's create it as return func. So in this case, it can return another function like return function and console.log of hello. Okay. Now if I call return func, so it is a function which is returning another function. So if I get this in a variable, this return function is having this function as a value. So if I want to execute this particular function later point in time, I can do simply like ret fun as a function. Okay. So what will happen? In this line, return function is going to return this particular function. This function, imagine that this is going to replace this particular variable. So this function and then the parenthesis means it will get executed. So it will print hello. Let's see that. So I have hello. It means we have now learned something called a higher order function, whose characteristic either it can take a function as an argument or can return a function from it. We have learned both the variants of it. Now where it will be useful? This will be useful mostly to create wrappers. So if you can see here that we are creating the wrappers, there is a functionality. We are wrapping the functionality inside another function, so that wherever this particular function is required, this particular functionality is required, we can utilize it in a different context. All right, let us now learn about arrow function. What is arrow function? Arrow function or the fat arrow function is a syntax that got introduced in JavaScript, in the modern JavaScript. We usually write function like greet me, and then you have the function body, say console.log. Now this one we had converted to function as an expression. What we did that time, we have taken this greet me out, we have put it over here and did a equal sign to make it as an expression and put a specifier over here, later const. All good. Now for arrow function, the syntax is much more simpler. You don't use this function keyword at all. That's the first thing. Second thing, you are using this parenthesis and this body, right? Between the parenthesis and body, you will use a arrow symbol, which is a combination of equals and greater than symbol. So equals and greater than together, there will be look like an arrow. So that arrow symbol, you have this arrow function. So this is your arrow function. Now this arrow function, you can pretty well invoke just like any other function, and it is going to log hello for you. Okay, it is logging hello. Now there are a few more things with arrow function that you can learn. If your body of the function is having only one statement, you can pretty well omit these things, just like we have learned it for if and else. So this is also a valid syntax. You have greet me equals to, you have only one statement, so you don't have to put it inside the curly braces. This will work and give you the output as well. We still get hello. Excellent. Now how about when you are passing some parameter to it? Of course you can pass it. Let's say you are passing something called a greeting message. Now this greeting message you want to use over here instead of hard coded hello. So now with greet me you can pass hola. It is going to print hola for you. Great. What if instead of console.log you just want to return something from here? So for example, you want to return, let's say, greeting message plus great. That means if you pass hola, it will be hola great. If you pass hello, it will be hello great. You can do this as well. And if you notice over here, if it is a single statement and you're returning it, you really don't have to write the return statement. You are not writing return. So it is this way. If you're using arrow function, if you are having the single statement and if you're returning, in that case, not only you can write it in a single line, but you can also omit the return statement. But as it is returning now, I have to print it. I have to definitely do a console.log outside so that I can print it. Like if you have multiple statement and from there you're returning, you must have to keep it inside the bracket like this. Don't forget that. And then you have to explicitly give the return statement if you have multiple things. For example, if you have something over here, then something over here, finally you're returning, this is how the syntax is. Okay, just keep in mind. Now there is one more thing with arrow function is called how this keyword behaves differently for arrow function. Again, an interview question. I'm not taking it here because I'm not teaching you this here. And in the beginning of this session, I have told there is a separate session coming in the module 2 for this. That's when I'm going to teach you for regular function, for arrow function, how the value of this behaves differently and why it behaves differently and what kind of impact for that you have in your programming. But for that, the precursor is to understand how arrow function works. What is arrow function? That is what I have explained over here. Hope it is clear. Let's move to the next one. So we have reached almost towards the end of the session. We have now IIFE, immediately invoked function expression we are going to talk about. After this, we'll be learning about the call stack and then recursion, and then we are done. So what is IIFE? Now, I have taught you guys about something called group operator, that is with two parentheses in the operators and expression session. That's why I say don't skip the earlier videos because it will be useful next. Now, with this operator, what happened is we are using this already for the function execution, passing the arguments, function declaration, passing the parameters, isn't it? How do we create anonymous function? That also we have learned. Anonymous function is a function that doesn't require a name. So that means it can have like function and then it can have anything like console.log, let's say IIFE, let's say IIFE. So this is an anonymous function and this is the parameter to execute the function. But if I just leave this thing alone like this and I'm going to my browser console, I'm going to get an error saying that syntax error function statement require a function name. Is asking for a name, but I'm interested in creating anonymous function, so I don't require to give it a name. And all these things that I am doing because I am going to invoke a function immediately with its creation. So far, any function that I was creating, I had to call it explicitly later point in time with its name. But as I am creating an anonymous function, I don't have a name, so I don't have to call. But I want to execute it immediately whenever I'm defining it. But this syntax is saying function needs a name. Now, to mitigate this, you have to use something called a group operator. And this group operator, you have to put around this function declaration and then the pair of parentheses for passing any parameters. Now, in this case, you have created an IIFE, an immediately invoked function expression that will be executed immediately after its declaration. So here the declaration is happening and due to this group operator, it is getting executed immediately. So if I go to now console.log, I'll see IIFE very clearly. See here is got executed. Now notably, I have not called this function anywhere later using its name or any other means. I have just invoked it the moment it has been declared. This is useful where? This is useful in most of the cases like when you are doing a plugin development, you want your plugin, the moment the JavaScript gets loaded on the browser, you want plugin to be executed immediately. Nobody has to explicitly call. The moment your JavaScript file gets loaded, how the JavaScript file gets loaded using async, I have taught you in the first session. So think about a file, inside that there is a IIFE code and you are loading that file in your HTML using async. So you are not really halting anything on your DOM rendering, on your DOM creation and all these things, because this particular code has nothing to do with your DOM. Let's imagine. So the moment this code gets loaded on your HTML, this gets executed, maybe it will bring a chatbot for you. Maybe it will bring a WhatsApp logo for you, whatever it is, it can do. So once you want something like that independently to execute without being called, you will be using IIFE. Now, one more thing, if you have to pass a parameter, so for example, I want this function to take a parameter, say count, and maybe I will do IIFE comma count. That particular parameters argument you can pass over here. So now it will log IIFE comma 1 because I have passed 1 as an argument. Let's see that. I see IIFE comma 1. So in an IIFE, you can also pass an argument like your normal function, and this is the way you can achieve it. I hope IIFE is clear to you. Now let's understand something very fundamental. It's called call stack. Again, we'll understand this call stack concept at a high level based on whatever we have learned so far, and we'll get very deeper to call stack when we do execution context video, and then we'll go further deeper when you do event loop. So anything that we are learning now is directly associated to what you are going to learn next, so please learn well. When function executes, JavaScript engine maintains a data structure to track the execution of that function, and the data structure is a stack structure. Stack is a very basic data structure. So whenever a function has to be called, the function will be put inside a stack, and once the execution is over, it will be taken out of the stack. This particular stack is called function execution stack, or there is another name, is called call stack. The image that you see on your screen is the call stack, where if one is the first one about to get executed, get inside the stack, then F1 would have called F2, so F2 got inside the stack. Then F2 would have called F3, F3 got inside the stack. Now if F3's execution is over, F3 will go out of the stack. Once F2's execution is over, F2 will go out of the stack. Then F1's execution is over, F1 will go out of the stack. And once stack is empty, then stack will wait when the next function execution pattern come, and then again that particular function will get inside the stack for its execution to complete. So this is what a call stack is. Let's see with couple of example like how we can simulate this call stack stuff. So the first one is an example where I have three functions. One is F1, F2, F3. Look at the left side where you have F1 function and a bunch of code, then F2 a bunch of code, then F3 a bunch of code. And below that I am executing F1, then executing F2, then executing F3. Here F1, F2, F3 are getting executed independently. So imagine you are JavaScript engine, you are JavaScript interpreter. Now you are looking into this file from the top. So you found F1's declaration, tuck, 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 great. Then F2 declaration, okay, great. F3 declaration, great. Now you found F1's call or invocation. You are calling or invoking F1. The moment that happened, what is it going to happen? You mark F1. You're seeing left side, the F1 is marked and it is going to get inside your right side call stack. F1's execution is over, so F1 will be out of the call stack. Then F2 will be marked for execution. F2 will be put inside the stack. F2's execution is done, over. Then F3 is the marked at the left side for execution. F3 execution is over and F3 is out of the stack. Awesome, isn't it? Now take the same F1, F2, F3, but the execution pattern we're going to change. In this case, you have F1, you have F2, you have F3. But the difference here is, in F3, you are calling the function F2 inside F3. So when executing F3, you are calling F2 inside it. At the top of it, when you're executing F2, you are calling F1 inside it. On top of it, you have the definition of F1. Again, think yourself as JavaScript interpreter. You are going line by line. First, you are saying F1 definition, good, great. F2 definition, good, great. F3 definition, good, great. All definitions are over. But till now, there is no execution. So there is no need of call stack till now. But the moment you hit the line F3, you see you marked it. So F3 goes inside the call stack. Now, as F3 goes inside the call stack, inside F3, you have F2. Now, F2 is another function. So you will be now executing F2. So you have to put F2 inside the call stack. And you mark the F2, you put F2 inside the call stack. F3 is not out of the call stack in this moment because you are still executing F3, as in inside F3 there is F2 and F2 is now getting executed. Until F2 get executed and come out, F3's execution is not over. So now F2 is getting executed. It has few lines of code, cut, executing. Then it hit F1. Oh my God, this is another function. Let's put inside the stack. F1 got executed. F1 got inside the stack. Now F1 doesn't have any other function call inside. So F1 will be executed and come out of the stack. Then F2 will be executed, come out of the stack. Then F3 will be executed, come out of the stack. This is how your call stack or the function execution stack keep tracks of each of the function executed, each of the function execution. Depending on how the functions are wired, depending on how the functions are wired up, one function is calling another function or functions are independently getting called, the execution and the flow in your stack will be different. That's what we have learned. Now, please practice this with pen and paper with different combinations, I would say, and follow the task also that I have given is very important. Please practice that because this is what is going to be the basis for understanding execution, context, and also event loop in future. I hope you liked it. The last topic of the day is recursion. Recursion is about a function is calling itself. It recurs, means it's calling itself. So if I take a function foo, and here I call the function foo. This is what is pure recursion. But when you do a recursion, you have to keep in mind two things. One, why do you need recursion? Because recursion has a cost. I'm going to show you the cost. Second, if you need a recursion, you need something called and exit criteria or the base condition. Both I'm going to explain. But first, let's understand the cost. Here I am having a function called foo, and inside the function, I'm actually calling same foo. So again, foo will be called, again coming here, foo will be called coming here. So it's like going, and resulting into, oh my God, something like uncaught, range error, maximum call stack, exceeded. We just now learned about call stack. So it's a stack, right? It has a limit, the memory limit. We have reached that limit by calling this function. So what was happening? Now try to visualize, close your eyes, visualize that call stack. Foo gets called, foo went inside the call stack. Again, foo is calling foo, again foo got inside the call stack. Again, foo is calling foo, again got inside the call stack. Gone. Nothing is coming out because the execution of foo is never getting over. It is already executing. So call stack will be completely filled, and once it is crashed, say maximum size reached. For that purpose, you need something called an exit criteria or the base condition. Let's understand that. Let's take up one more function called fetch water. And let's take a count, and let's take a console.log, say fetching water, and then print the count. Now I will do fetch water, and I will decrement the count by 1. So what I'm doing, I'm having fetch water count, let's say I'll pass 5. So fetching water 5. Now 5 minus 1 will become 4. So fetch water will be called again with 4. Fetching water 4, then fetching water 3, fetching water 2, fetching water 1, 0, like that it will go on. Now this also will result into similar kind of problem we have seen with foo. So if I call fetch water, let's say 5, is going to hit the same problem like foo. Yes, fetch water, maximum call stack size exceeded. So now we need something called a base condition, and this is the exit condition. So you should always think that I can use recursion, a function calling another function, but I should have a way to come out of that recursion, and that is completely depending on your use case or your business case. In this case, my business case could be if count is 0, when count reaches 0, that is the time we can say console.log no more water is left to fetch, and I will return and come out of this function. This is what my base condition of the exit criteria. Now what will happen for number 5? It will say fetching water 5. Is 5 is equals to 0? No, this won't be executed. It will call count minus 1 means 4. So for 4 also no. Then 3. For 3 also no. 2. For 2 also no. For 1 also no. When it's 0, that time fetching water 0. Count is equals to 0. Yes, it is 0. It will say no more water left to fetch. It will return from here. So this fetch water will never be called again. So that means we broke the recursion based on a base condition or the exit criteria. So now we won't get the error that we have seen before. Rather, we'll get a logical way of seeing this fetching water 5, 4, 3, 2, 1, 0, no more water to fetch. So this is what is recursion, guys, and this is how the recursion works. I want to know if this was useful to you, this was helpful to you. Please let me know with a comment. Please like this video if you liked it. And again, the request is to share about 40 days of JavaScript in your circle, in your social, so that more people can come to know about it. And if you are someone who is still thinking whether to subscribe to tapaScript or Tapas Adhikary's channel or not, I think it's time. You can do that. You won't be disappointed, I guess. And the last thing would be the task. You will find the task in the repository. The link to that particular task is there in the description of this video. Go to this repository. You will find day 06 as a folder. Go inside that. You will find the task.md where all your tasks are there. Please, guys, try to complete the task, because with that only you are going to learn a lot. And once you complete it, please come to our Discord. And coming to our Discord, you can discuss the task in the task assignment channel. You can drop your task link, or if you have any questions that you want to ask us as a community, please go ahead and ask us. Whether myself or anybody else from the community will pitch in and try to answer your questions so that your learning becomes complete. Though we take time to learn, but we learn in such a way that we never forget. That's the way to go. Invest your 1 hour right now so that saves your 1,000 hours later point in time. That's the motto, guys. In the module 1, there is only one video now left to do a project with everything that we have learned so far. That's what I'm going to do next. That ends our module 1, and then we'll start with module 2 soon after that. Take care. Thank you.